What can we say about the cardinality of a domain and a codomain where a function f is given to be both 1, 1 and onto? You see, when a function is 1, 1 from a domain D to a domain codomain C, you know for sure that the number of elements here on the right wing is greater than or equal to the number of elements in the left wing, which means number of elements in C is greater than or equal to number of elements in D. Given that f is 1, 1, but I'm saying something else as well. I'm saying f is also onto. Now 1, 1 means C is greater than or equal to D, I mean cardinality of it, right? And onto means no element in the codomain is left out. Okay, which means number of elements in codomain is less than or equal to number of elements in domain. That's what onto stands for. So look at these two statements. They both put together gives us that the number of elements in C is in fact equal to the number of elements in D. Where did I start from? Where did I conclude? What did I conclude? Where did I start from? I started from the fact that whenever a function f is 1, 1 and onto from a domain D to a codomain C, both with finitely many elements, we call that finite cardinality. Then we conclude that they both should be of the same size. Alright, so let me give you an intuition of what I'm trying to say here. I'm trying to say that whenever you have two sets and you want to show the number of elements here is equal to number of elements here, you can simply give a bijection. Bijection means both 1, 1 and onto a function. Give some function. Then you're proving that they are of the same cardinality. Conversely speaking, if they are of the same cardinality, you can actually give a function f which is both 1, 1 and onto from this set to that set. Let me illustrate a nice example here. I take 50 chocolates to my class, distribute 1 chocolate each to every student in my class. By that I mean I give 1 chocolate to a student and every student gets a chocolate. And at the end of this exercise, no chocolate is empty. I repeat, every student gets a chocolate, no chocolates are empty. I entered the class with 50 chocolates, which means basically I'm creating a bijection from 50 chocolates to the students here, right? 1 goes to 1 and nothing is left empty. So I'm giving a bijection here, which means the number of students in my class should be precisely 50. So exhibiting a bijection comes in as a very handy tool to show the cardinality of a set. Sometimes you may not know the cardinality of a set S, but you may know the cardinality of set T. In that case, you exhibit a bijection from S to T, and then you can conclude that given that you know the cardinality of T, the cardinality of S is supposed to be the same.